Everyone ready for some open source security? Yeah? Awesome, cool. So this is what I want to talk to you today about open source security. Why is it so important? Why, for every one of us, it matters, kind of like a web accessibility. So let's dive in. My name is Liran. I'm a developer advocate at Snyk, where we build developer-friendly security tooling for open source projects. You can go ahead and use that for free. I am also involved in some communities like JS Heroes, as we mentioned before by Alex. I am involved with the OWASP security project, so building a node security, node Goat project. It's an educational platform. It has some vulnerabilities to have you experience with it. I'm also passionate about CLIs, so I build a lot of cool stuff like that because I'm kind of CSS challenged for frontend. I wrote a book about essential node security, and I take part in the security working group for Node.js, the foundation. So I'd be happy to talk to you about any of these topics afterwards if you want to. I'm on Twitter at Liran_tal. So with that, let's start with what a better way to begin with. Open source is just awesome, right? We use it all the time. We use it. We contribute back. It's hard not to be affected by it. It's something that is kind of part of our daily lives. As a testament of that, we have the NPM registry almost spanning 1 million packages, which is an amazing growth. I believe that just last year, it had added 250,000 packages, just 2018. So, open source is there. And we might think that open source is written by people. I'll get to that in a second. But let's ask ourselves, what do we really know about the dependencies that we're using? So imagine your project. You might be doing that in a front end, in a back end, NPM, JavaScript-based project. And say you're using Axios or React or Express or any other very popular dependency and library that probably everyone here in the room knows. But try to think about it a little bit more deeply and ask yourself, what do you know about that specific library? What do you know about the dependencies that that library actually brings and bundles with it? Do you know the authors? Have that library undergone through security testing, through security controls? Are the authors that actually, the maintainers that actually wrote the library, do they have any kind of security knowledge? Is this something that is bundled? So if you think about it throughout, you'd see that we have less and less understanding in terms of all of these dependencies that we are bundling with our applications. So it's kind of written by strangers. And I would say that most of us are kind of unicorns, right? We are trying to bring value to be something bigger than ourselves and kind of create a better world through open source, share projects, learn, understand. We all have kind of good intentions. But when we try to survey those maintainers, and I asked in that survey kind of 500-ish more maintainers, some questions about security. So I asked them, let's let them rate their security knowledge from low, medium, high. So only 70% of maintainers actually don't have a high security knowledge, right? So 70% of all the NPM packages that you're using probably have maintainers with no high security knowledge. More than that, let's go in terms of, well, we're using open source packages, right? Are they being security audited? Is someone doing security code review for their packages? And I'm not talking about small packages that probably no one here in this room uses, like maybe LeftPad or is odd or right that didn't break the internet just a year ago or so. So I'm talking about bigger projects. 1 out of 4 maintainers does not go through security testing for their projects at all. You can count 1, 2, 3, 4 your dependencies that did not go through security testing. You have no assurance in terms of the quality of security for that dependency. I would say that another aspect of security is our own developer security. There's a great talk in terms of how developers are kind of the vehicle of malware distribution, right? And we've seen it in so many cases. I will talk about a couple of those just in the next slide, but I wanted to share with you this tweet from a couple of months ago from Adam Baldwin. He's a security guy at NPM, the registry that you all know. And he had shared that only 7% of maintainers have 2FA enabled. So that's kind of a scary thought. So as we're talking about security and the security for dependencies, we are seeing that there are some issues some incidents that have happened on our ecosystem. I think that crossenv is, how many people here have known crossenv? Great, it's a great package if you install this one. Basically what it does is it provides you with environment variables management at the point where it's also stealing all of your environment variables and all those API keys you're storing in them and sending them to a remote server. That's a great package. ESLint scope is, how many people know of that one? Cool. So ESLint is, you know ESLint probably as the static code analysis. ESLint scope is a viable project. It is okay. But apparently ESLint scope specifically was compromised and a specific version of it was published. And when it got installed, it stole all of your tokens, those that you put in npm-rc. And if you're a maintainer, you probably have those tokens there. And it also sent them elsewhere. And there are only a couple of projects, like small ones, that use ESLint scope, like Webpack and Bubble. Don't know if you heard about those. Flatmapstream is a malicious package, kind of to end those three, that was introduced into EventStream. I think that's the most probably well-known story that you have heard about. And all of those attacks, if you think about them, they are malicious packages that were added into the registry, but in all of different ways. So EventStream kind of made use of social engineering attacks to introduce something malicious into a popular package that gets downloaded 2 million times a month. ESLint scope was compromised because an author didn't have 2FA enabled, and so someone was able to use his password. Maybe that was 1234566. I will tell you more about that afterwards if you're interested, because there's a research around it. And crossenv is a form of typo squatting attack. So all different kinds of attacks that have affected us or could have affected us potentially in some way. So a typical JavaScript application, and I think this is something we can all relate to, is made up of maybe hundreds, maybe thousands of dependencies, both direct and indirect. Here's a serverless example built on the serverless framework. I wrote it. It just fetch a file and uploads it to S3. How many lines of code do I have there? Very good. 20 lines of code. About. Just about. How many dependencies am I using? I'm using 2 first. But that's a good answer because that means you're already thinking about all those nested dependencies that I'm bringing in, right? 19 of those. AWS SDK and Node Fetch is a polyfill for Node. But how many lines of code am I actually pushing now to production, to the systems where I'm deploying? Is that really 19 lines of code? Hundreds of lines of code. All right, how about 200,000 of lines of code getting pushed that I didn't write? I have no security code review and no security understanding into what attack surface are those bringing in, right? This is what we have to deal with. If nothing else you would take out of this session, I would say, while you're thinking this is your app being deployed, your code is really just a glimpse on the radar for this application, and that's what really gets deployed. Let's talk about some application security challenges. We're all in the software development industry, developing software. One of them is, how do we keep up with software development getting released, right? Daily commits. Can all of you, or at least one of you, say that every time you commit, you release maybe once a week or twice a week, or maybe every 2 weeks, just kind of doing the Scrum thing? Can you say that every release like that has undergone through security testing properly? Probably not. It's something that we're really lacking in the industry. Lack of security knowledge, right? And security people. So I don't know if this statistic is going to be new to you or not, but for each 100 developers, the ratio number is 1 security person in that organization. And that's a really high ratio. That's a really good one. So we are, as security engineers, we are completely and outrageously outnumbered in terms of being able to deal with security, self-security development in our applications. And if to think about another challenge, right? No one teaches us about security at school. Like, this is not a basic CS studies courses. We all kind of learn about it like we learn about accessibility and some other topics. It is not a mandatory topic in any way. So what happens when we neglect to address security in our applications? Let's talk about Equifax. It is a fairly very known incident for a company called Equifax that had their data breach a couple of years ago. So I'm going to use that as an example. They were a data analytics company, had something like 140 million data records leaked. How did that happen? Well, they used a Java application, dependency library, Java struts. It was known as vulnerable, or published as vulnerable, disclosed as vulnerable by 2017, March 2017 to be more exact. It had a security disclosure responsible. There was a fix early after the announcement, so anyone could have taken it and, of course, patch their servers, right? All we have to do is just not use dependencies and components with known vulnerabilities. That's kind of part of the OWASP top 10 web application security risks. Except Equifax didn't do it. And they missed on upgrading that. They missed on moving that server out of the internet. They missed on somehow remediating this vulnerability. And so for a couple of months, they had that server basically being vulnerable out there on the web. Someone hacked through it to the rest of the records. That was just a point of entry. And they only found out about it later on. And when they did, as kind of a retro and postmortem thing, they realized that someone hacked them kind of like 2 or 3 months after the vulnerability was published. So really, this is one of those vulnerabilities, one of those data breaches, one of those security incidents that could have been prevented. So with that, what I want to do next is maybe kind of a live hacking session with you together. We'll try to learn about some vulnerabilities in our applications and how they work. So this is my to-do app. I will tell you later if it's written in React, Vue, or Angular, if you're that interested. So it's a normal to-do app. I can do things like talk about web accessibility. And as a security personnel, right, if you are security-minded and you have maybe QA that is security-minded, you would try to go and maybe XSS injected sensors like user input, we can play with it around. So any ideas from the crowd? Maybe like this, right? Cool. Oh, there we go. So what I want to show you else is, let's talk about a problem where this application is using Markdown. Does anyone know Marked? It's a very popular NPM dependency. 2 million weekly downloads. It helps us write Markdown, so I can do things like, hello. Oh. Like that. But then I can also try and inject some malicious XSS through this way. How could I do it? Very similar to how I have done it before. I can use script, right? Yes. So I can use things like that. I can say, I can use something like this, right? But here I can go and do something like that. That doesn't really work. So what can I do to try and overcome it? Marked has this flag that sanitizes input. So it is open source. I can just go into Marked source code and see what's going on. And as I would go in, I would see that maybe it searches for JavaScript colon. And I can go and encode that in a way that would later be translated into a colon for the web. So I can go and do something like this. And I can go and encode this as well. And honestly speaking, what I would want to also try and do is kind of escape it in a different way. So let me restart this server and try this again. And let's see that our templates are actually using the sanitization function as Marked is able to do. So we have it here. Yes, and if we go to our app, so sanitize is false. So we can do it like that. And I'll restart it. And I can now do the same thing and it doesn't work. So marked has this way to kind of escape XSS, right? Looks kind of good. The only thing is there are some ways, in the mysterious ways that the web works is funny. So if we look again at marked source code, I could go into and see that actually marked is kind of smart in terms of sanitization. It tries to look for these strings, and then if it sees them, it will go ahead and replace them. So that's why it didn't work. But browsers are funny in a way that they would try and help you accomplish things. That's why front-end developers love them so much. So if I were simply to put the word this would work. But why? Why on earth does something like that work? Right, it's failing, but not at all, not just that, right? So marked is unable to match that because it's passing sanitization. And then the browser says, well, I think you meant to close it with a semicolon, so I'll go ahead and add it for you. And the rest of that is a valid JavaScript expression and statement, this semicolon alert. So that's why it works. So first XSS injection that we have seen in our application. And if you go to, marked is a very popular vulnerability, dependency that has some vulnerabilities that you might want to be aware of. Kind of something that we're trying to improve in the ecosystem is sanitization is actually, right now, it's actually enabled by, it's not enabling that by default. So I had to actually opt in to security, right? That's kind of something that I would want someone to think about it and enable that already for me. All right, cool. So let's look at some other stuff that we have. So we also have this, this endpoint here called about new, which is showing some text. And then I can go in and do device equals desktop, and then maybe I would see it smaller scale or bigger scale. That's nice. And as I try to maybe exploit it and find some weird stuff, maybe I would go in and try to add a quote. So maybe I would try to escape whatever it's doing inside. And I see that it actually is guarded upon, right? So what I'm using here is a library called Dust. It's actually Dust.js by LinkedIn. Let's see if we can easily find that. There we go. So it is fairly popular, not as much as before. It is a server, one of those server-side templating engines, stuff like EJS or handlebars. And we use that sometimes to get things done. And as I'm seeing that it's doing something odd, I can go in and figure out like what's going under. So it has this escape HTML, which is a function that tries to do the exact thing that you would want the library to do, right? It's trying to match all of those strings and quotes and escape them as well so that it encodes them so they aren't printing to the screen or getting passed in the wrong context. So this is great, but one thing you might have noticed here is that it's actually using this if statement that it checks if something is a string. So what if I were to try something like, maybe I'll represent it not as a string. Maybe I will go ahead and use pass it as an array. This is where I would make use of something known as HTTP parameter pollution, which is a way for me to specify different occurrences of the same thing. So I could go like device equals something, and then device equals something, and then what would the server side expect to do with this? Is it an array? Is it like the last one it takes in? I don't know. Let's see. So one way to represent those kind of array is by giving them like these square brackets, which I can see that it works kind of well until I try to add quote, and then I'm seeing things starting to unfold, and something is happening. So it's actually saying that it fell due to unexpected string, and pointing me to Dust.js helpers, which I can see, take a look at what's going on there. Dust helpers. There we go. And Dust has these helpers which allow you to build those templates. And one of those is an if, so I can build templates based on conditional logic. And as it takes something, it tries to evaluate it. Right? That's how it works. And Dust is a very legitimate, templating engine that was actually built to be secure as well. So to give you more context into what's going on in the background, this is my template. And you can see how this works. So this is not security vulnerability by itself, right? It's a functionality, it's a capability for you to do things like if condition, and then all the condition is added here with the interpolated input from the parameters over there. So let's try to think about it a little bit, right? So what's happening is something like this, which makes sense so far. But what I can do, as we've seen, I can actually inject something into eval. So that's why it failed before, because it couldn't really evaluate this as valid JavaScript. So what if I were to kind of escape this desktop wording input and try to do something as simple as telling it to kind of do math operation between several expressions, so like desktop and then console log. And what happens is that it tries to kind of resolve this and compare that to the desktop on the right. It actually executed because that's a valid expression, right? It's looking for a value. So I can do the same thing from a request from outside. So I would be doing something like this. So far looks okay. And I can go ahead and represent that. I'll escape it so the shell doesn't yell. And reproduce the same thing that we saw in the browser. So it had tried to evaluate. You can see some debug stuff of what we sent, unexpected string. And we're on a good way. So let me put that on the top. There we go. And I can go ahead and say, well, how about I give you this input, see if we structure that correctly, to kind of go through the if condition and evaluate to something that is true. And as you can see on the server side, I actually executed that console log. So I'm like one step away from doing something very malicious, right? From going and doing something like require process, child process maybe, spawning something, doing something very malicious on it. So to give you more context into what's going on, basically this is a code injection that lives in Dust, and there's a way to fix it, of course, by upgrading the library, but maybe if you're not following and checking your open source dependencies and projects to what you're developing, you might be missing on things like this happening, and you might not know about it. So maybe another demo before we move on a little bit more is I also have this humanize MS dependency, which I use it to, anyone uses MS? Heard about MS? Converting time to microseconds? Okay. I don't know under which rock you were living, but that's pretty popular. Oh. All right. So a vulnerability in that affects a lot of things, both server-side and front-end side. So I'm going to use MS, and I will do something like, let's go back here to user input. And I would go and do something like do accessibility. See, Alex, I'm learning here in 20 minutes. I'm that dedicated. So MS is great, right? It allowed me to format something like in 20 minutes to 20M and represent that in a different way. And maybe that's some kind of feature that we needed to work with for our product, for our features, whatever we're building. Except, how do you think MS actually works when you do something like that? Any ideas? Yes. Who said that? Great. So thank you. So it doesn't do machine learning. It doesn't do artificial intelligence. It doesn't do WASM. It does regexes. Who likes, if it does blockchain, I will have to PR. If it doesn't, and I will add it. So who likes to write regexes? Great, 1, 2, 3, 4, 5. Horrible people, all of you. I'm going to ask the same people now, which one of you likes to read the regexes? I don't think you like to read it, but okay. All right, cool. So it does it using regex. And what little do we know about regexes is they have associated with vulnerability issues, because regexes are, little do we know, they are CPU bound. So they are running tasks dependent on the CPU. And they do not all work very, very fast. Sometimes it takes a long time for something to work. For example, as I will try and add something here. So it's this one. There we go. So it's sending a post request to 3001 create, and it's a form with content hello. So I can go ahead and try and replicate that from the server side. So I can do something like content. I'll go with buy milk in 20 minutes. Send that off to HTTP, specify that it's a form. And if that worked well, we have it. So far, so good. What I can also do is, I know it's a regex, so thinking in a security kind of mindset, maybe I'll try to give it more input. So maybe not 20 minutes, maybe many, many, many minutes to try and evaluate it for a long time. So I can use a tool like sequence, format the string maybe 5, separate it with nothing, and repeat that thing 100 times. Let's do it. Let's repeat it 60,000 times just to make it fun. We'll hope my laptop doesn't crash. I will open a processing monitoring, and I will go ahead and send it. And as I did, it shows infinity, which so far is still okay. That's not a vulnerability by itself, and as we would expect. But then what happens when we kind of gain a bit of more understanding into how regular expressions work? So think about a regex, and regular expressions exist in different kinds of engines. They are kind of split between a non-deterministic and a deterministic state machine that tries to evolve, and there are different trade-offs between how it works. So if you think about a regex, and the way that it would work, for example, is imagine a maze. Someone, there's a mice maybe at one of them, and the cheese at the end. So regex would go and try to go through all the possible paths. Didn't find a way, would go back. Would try another one, would go back. So just to explain this, regexes are built on something that is called the backtracking algorithm. What that does is it tries to match all the possible tokens that it has with your pattern. And if it doesn't find a match, it's going to go and try a different way to match them. So essentially, it is backtracking like a stack, one character down, and trying to match with the rest of the tokens that it has, the rest of it. And as it does this, if a regex is written in a very poor way, in a very bad way, we can exploit that and create something that is known as regular expression denial of service. So we can let the regex run for an exponential amount of time until it evaluates. So for me, knowing that, I can just go in and say, well, I know you're looking for minutes. Let's change that to minute A, and try to run it. And you can already see my node process on the bottom running at 100% CPU. And if I add some stuff here, my process is stuck, and only after a bit, it gets out of it. So what we have done is actually affected the node side of it, of the JavaScript engine. The event loop kind of blocked it from processing any other requests while it was trying to evaluate this one. So, going back to understanding those vulnerabilities. So we've seen a couple of them, right? We've seen XSS, we've seen things like regular expression denial of service, which affects the browser, as you've seen as well. We've seen things like remote command injection, right, that happens through templating engines. And you would want, right, a way to kind of fix it. So let's get back and talk about open source vulnerabilities. So attackers, it is, I think, becoming apparent that attackers are targeting open source because one vulnerability, just one package in Axios or in anything else translates to many, many victims, right? Because we are working in an open ecosystem where it's probably not just one or two people using something like Express or Angular or anything else. And to give you another perspective of why it is so difficult and challenging to address open source security, so a part of that, actually, it's a big report in terms of evaluating the state of open source security. And what we have done there is also trying to look at the data that Snyk has on its customers. And what we actually follow is not your code. We are following your package JSON, your dependencies, your manifest files, so things like a log file. And using that, we're trying to also help you and automatically fix your dependencies. So what I can do is I can go into Snyk's database, and I can open and create a chart like this, which tells me that 78% of the time that we find vulnerabilities in NPM projects, they would be in indirect dependencies, right? That's a very hard challenge for developers to handle because it is not those dependencies that they are looking after. It's not that if you are tracking the changelog lists and security mailing lists for Angular and Express and React and Vue, whatever, and you are very responsible, that's amazing. But that's not where most of the vulnerabilities come from. It's from all those side vulnerabilities, those nested vulnerabilities that are kind of brought in when you add a project, when you're not building just on specific one dependency. So that's a challenging part that we are trying to help the ecosystem and build with it. But what if I told you that security was easier, right? What happened if security was more developer-friendly, if you had great tooling that would make you resolve and take action on those vulnerabilities? What if we wouldn't just tell you about security vulnerabilities in this and that package, we'd actually go and fix them for you? So what if we would open a pull request to tell you, well, I found the vulnerability in this and that package that I'm tracking for your project, since you connected your GitHub repository or something like that. I went ahead, opened a pull request, I updated the actual minimal semver possible path for that dependency. So even if a fix exists in a major version, I will try and not let you move to that major version, but maybe a minimal version so that we don't also break APIs and not let you handle those kind of changes. So I'm going to do it in a smart way. I'm going to also relock your log file because if I were just to update a dependency, you would check out, another developer would change something, and their Git history is kind of changing, and that's not a very a comfortable situation to be at, even to not complex. What if you only had to see that the checks are passing and merge it, right? What if when a new developer were opening pull requests, adding dependencies or changing them or making some change, you would have that extra check that checks that maybe no licenses that are invalid for your organization would be added, and that no vulnerabilities are added with dependencies that you add to the project. So all of this is possible. Thank you very much. I hope you take security in a very responsible way, use open source, and thank you for being here.